Hi, it's Cisco with Acrobotic, and I'm here to share with you another tip for working with your ESP8266 microcontroller. In other videos, we've seen how to set up the ESP8266 as a web server and how to send web pages from that server to any client that requests them. To serve and request those web pages, we've used HTTP. And we've also seen how to add JavaScript to update data that's displayed on the web pages. Today, we're going to be using WebSockets, one of the latest web technologies for exchanging data between a web server and a web client. And we're going to be doing it using the ESP8266. For this tutorial, I'll be using the Wemos D1 Mini development board. I'll leave a link to my little Amazon shop where you can purchase them in the description of the video. But before jumping in, let's quickly go over what WebSockets are and why should we even care about them. Going back a couple of decades, the way the internet worked in its early days was by using the HTTP protocol exclusively. One of the implications that had is whenever we needed to see something new on a web page, the whole thing needed to be reloaded over HTTP. In another video, we've used HTTP requests to toggle the status of an LED on and off. Whenever we would click a button on the page, the LED would change state, and a different web page using an on label or an off label needed to be served. And the whole thing, as we can see down here, needed to be refreshed. Fortunately, in 1999, things changed for the better. XML HTTP requests were introduced, and that allowed us to change only parts of a web page using XML HTTP requests and getting responses back from a server. That allowed for things like dynamic web pages, most importantly chat applications. But using the ESP8266, we were able to see that now the whole page needed to be served only once, as we can see down here, but using those XML HTTP requests, we can achieve the same thing, just changing the label on the page and changing the status of the LED, but without having to reload the whole thing. You can see down here that the document it's only served once, and from that point on, we only send requests to the server and get the responses back in order to update the label. Then in 2011, a new technology was introduced by the name of WebSockets, and what that allowed was for clients and servers to exchange data using bi-directional communication. What that means is that no longer did the client need to send a request to the server in order to get a response, but each one of them could be able to send or receive data at any point in time using a WebSocket. And the main application for that was transferring data in real time. As you can expect, we'll be using JavaScript to set up a WebSocket. So I recommend brushing up on your knowledge about this language, because if you're working with internet connected devices, it's pretty much inescapable and it's a good thing to learn. As I do in most of my videos, I'll download the tips repository in order to get some code as a starting point. I'll go ahead and uncompress the downloaded file, and I'll open the web server HTML file. I'll go ahead and save it onto my desktop and give it the name webserver_WebSockets. I'll use the library manager under the sketch menu in order to search for the WebSockets library. I'll go ahead and install it. It's the last one from the list. And I'll go ahead and start working on this file. The first thing I'll do is include the library by using an include statement with its header file, WebSockets server.h. Next, I'll create a WebSocket server object that I'll name WebSocket, and it'll be running on port 81. We can specify the port using the parameter of the constructor. I'll go ahead and change the LED pin to pin number 2 because we're using the Wemos D1 Mini instead of the DevKit development board. And I'll put my network ID as well as my password. And I'll go ahead and get rid of the elements that were inside the body of the old web page that we were using. In our WebSockets page, we'll simply start with a text area that'll display messages that are sent from the serial monitor. I'll give it the ID RX console. Then, using JavaScript, I'll go ahead and create the functionality for the WebSocket. I'll start with a variable that I'll name socket, then with an user-defined function that I'll name init. I'll define the socket variable to be an instance of the WebSocket class. This class is supported by most modern web browsers. After all, it was introduced 7 years ago. It only needs one parameter that specifies the URL where the socket is going to be established. I'm going to be using the window object, the location host name to get that URL, and I'll be running the WebSocket on port 81. Then I'll simply override the onMessage method by a function that gives me an event, and that event will allow me to get the message that's sent through the serial monitor, and I'll use that message to display it on the text area. I can get the text area by using the getElementById method of the document object with the ID that we gave to that text area, RX console, and overriding its value attribute by using the data attribute of that event. Then we just gotta make sure that that init function runs when the page loads, and to do that I'll use the onload attribute of the body element to run it. Going back to the server side of things, we need to make sure that that WebSocket object runs its begin method, and inside the loop function we also need to run the WebSockets Loop method, as well as provide the data that is going to be sent to our text area on the page. To do that, we'll use the available method of the serial object, and remember, we've already initialized the serial object in our setup function. We can get the actual data by using the read method of the serial object. Then we can use the WebSocket object with the broadcast.txt method to send that to the WebSocket. That takes two parameters, the data itself and the size of it in memory. Lastly, we'll get rid of some of the functionality we used in the previous example, like this user-defined function, as well as this route, and we'll be sending the web page that we created before. Remember that we'll need that _p method because the web page is stored in flash memory. That takes three parameters, the status code, which is 200, the type of data we're going to be sending, which is text HTML, and the data itself, which is what we stored in the variable web page. Before this next step, make sure you've installed the USB drivers for the development board that you're using. We've done it for a few boards in other videos. also double check that you go through the Tools menu and select the correct port, as well as the correct port that you're using. I'll go ahead and compile the code, and with my board connected to USB, I'll hit upload. I'll open the serial monitor, get the IP address of the board, and open a new tab in my browser. I'll see that only a text area is displayed, and if I pull up the serial monitor, I'll minimize this, any message I type will be displayed in that text area. We can test it for as many messages as we want and see that the WebSocket communication from the web server, which has an interface over USB to the serial monitor, and the web client, which is the web browser that's running on my computer, that communication, which is bidirectional, is working at least in one direction. Let's go ahead and test the other. If we go back to the Arduino IDE and pull up our web page, then we can add a similar element to the page. It'll be a little text bar that will allow us to send messages to the server. I'll put this inside a div element, and in between our text area and our text bar, I'll just have a horizontal rule. I'll go ahead and put the text bar inside another div, and that'll be an HTML element of type input. I'll specify that it's going to be a text bar. I'll give it the ID TX bar to remind us that this is transmitting data from the client to the server. And lastly, I'll use the onKeyDown attribute, which happens when a key is pressed. There are a few events that trigger using JavaScript, and I'm going to be using the one named onKeyDown. I'll use it to determine when enter was pressed in order to send a message, and I can get that by using the keycode attribute of the event, and when that equals 13, I know that enter was pressed. So when that happens, I want to call a function that I'll define next that is called sendText. I'll go ahead and define that function now. And what that simply will do is send using the send method of the socket object, and what that will send is the actual contents of the text bar at the moment. We can get the contents by using the getElementById method of the document object and the value attribute of that element. Then we'll want to reset the contents of the text bar. To do that, we simply use what we had before and we set it to empty. Once we're done with the web page, we need to make sure that we do something with that data when it's sent to the WebSocket. So to do that, we're going to be using the onEvent method of the WebSocket object. That takes one parameter, which is the name of a function that we'll define. I'll call it WebSocket event. Go ahead and define that function. Since we're overriding a method of the class, we already know what parameters we can use. The first is an 8-bit unsigned integer that I'll name num. Then there is a WebSocket type that I'll name type. Then there is the actual payload, which is a pointer to an 8-bit unsigned integer that I'll name payload. And lastly, it'll be one of type size that I'll name length. Then we'll use the type to know what type of data it is. This is just for double checking that indeed we receive what we're expecting. we want to go ahead and display it on the serial monitor. And to do that, we need to print out each character at a time. So I'll use a for loop, the length of the payload, and the print method of the serial object. I'll typecast the data to char and go through the entire payload. After that's done, I'll simply add a new line. We go ahead and upload the new code. You can go ahead and open the serial monitor, minimize the Arduino window, reload the web page, and anything we type inside that text bar will be displayed in our serial monitor. So now we have bidirectional communication. Go ahead and reduce the size of the window that we can see it in action. So anything I type here will go to a serial monitor, and as we saw before, anything that I type there will go to this text area. So far so good, but as a hardware guy, I want to make sure that we can use WebSockets to control actual hardware. So as a quick test, I'll be adding the functionality so that we can have a little slider on the web page that will allow us to control the brightness of the built-in LED. So I'll go back to my web page and more or less duplicate what we had before with the little divider, and the input, instead of type text, it'll be of type range with the minimum value of 0, that'll be the minimum brightness, and the maximum, it'll be 1023. Remember that it's a 10-bit PWM method that analog write uses. And the start value will be 512, right in the middle. We'll change the ID to be brightness. Instead of using the onKeyDown attribute, I'll use onInput, which means anytime the slider is changed, it'll trigger this JavaScript method. I'll be defining a new function that I'll call sendBrightness. And as you can imagine, that looks pretty much like sendText. So I'll go ahead and copy paste it. I'll rename it, of course, to sendBrightness. I'll get rid of this particular statement. And in order to distinguish between when we send text and when we send the values, I'll just simply create a string that is prefaced with the numeral. And then the actual value of the brightness I can pull by using a similar method that I was doing before with the right ID, of course. So that's it for the web client side of things. That is the web page that'll be served. Now we need to do something when those values are sent to the WebSocket. We go down to our WebSocket event, which gets triggered whenever data is sent by the client to the server, and it'll come through as type text. So now we can say, well, if the first character is a numeral, so we can do that with an if statement checking on the first member of the payload array. If that's equal to this character, then we want to change the brightness of the LED. Otherwise, we want to do exactly what we were doing before. So the brightness will be a 16-bit unsigned integer that I'll call brightness. I'll need to typecast the data that is coming in through the payload. And to get the actual value, I'll use the built-in string to long method that takes 3 parameters. And I wouldn't go into too many details as to what that is, since it comes as a single value. This is all I need. And it'll be of base 10. Because of how the LED is wired up on the Wemos D1 Mini, I'll need to invert the actual brightness. So it'll be equal to 1024, the maximum, minus the actual value that I get from the slider. Then I'll simply do an analog write to the LED pin, which we defined above, and the actual value of the brightness. Then, for debugging purposes, I'll use the print method of the serial object to print out the actual brightness. Remember, this is not sent by neither the client nor the server, it's just to help us out debugging what's going on. I'll go ahead and upload the new code, reload our web page, and bring up the serial monitor. And then play around with the slider. We can see that indeed the brightness is changing, and if we go to one side, the LED goes all the way to off and all the way to on. And you can see, just if I move this back and forth really quickly, how that communication is really smooth. So even though this is printed out directly by the microcontroller, the data itself is being transmitted in real time using WebSockets between the client running inside this web browser on my laptop and the ESP8266. So there you have it. Today we've learned how to use one of the latest web technologies, WebSockets, for exchanging data between a web client and a web server using the ESP8266. If you like my videos, I invite you to my Patreon page where you can chip in $1 or $2. That really helps me put in more time into the videos and release them quicker. But whatever you do, don't forget to like, subscribe, or leave me a comment. You can also interact with me on social media. I'm on Instagram, Twitter, and Facebook, and you can even use the community tab of the channel. Thank you for watching my videos, and I will see you next time.